Good morning. This is that awkward moment when Zoom and Facebook are talking together and I don't know at which point we go live. So as soon as I actually see my face live, oh, there we go. Then I've got to do something else over here. And so we'll give a few people a chance to come on. And what I do is I share it in a couple of places. So thank you for joining the group. Please do share it with other people. It's not on, hasn't come on my phone yet. Here we go. So please do share it with other people. This is all about helping parents with maths at home. And I've started doing this morning live. I usually do a live at 8 o'clock London time. I was having a chat with a friend in Malaysia who pointed out that, or made me aware of the fact that that means that loads of people east of here, really it's not practical to watch it. You'll be fast asleep. So I'm now doing this at this time. Hold on, I've got to, I don't know why they say women can multiplex. I ain't one of them. Share to a page. So I'm sharing it to the Bubbly Maths page, I hope. How do I change the page? This is, discard, sorry. Why is it share to a page, but then I want a particular page? Do that one. Okay, share. Making maths fun. Oh, I'll do that later. For parents, fun for parents at home. I said I'll do it later and I didn't stop. And then the other thing I've got to do is start a watch party. There we go, start a watch party. So I will be commenting on there, and then afterwards, any comments that come direct on here. Oh dear, dear, dear. You've disappeared. Oh dear, dear, dear. Where are you? Oh, there you are. Now, why am I looking there? No, I know where I need to look. I need to look here, so I know I'm seeing what you're seeing. Although that's a good point. I could. Has it stopped? Are you still there? Are you all still there? Just occurred to me that instead of looking at Zoom, I've got to get rid of that. Be my own technician. I will get good at this. It's kind of inevitable. I will get good at this. Now playing live. That says live, but I don't see the live. Refresh. Refresh, refresh, refresh. Are we there? Are we here? Are we on? Testing, testing. Oh, is that us? Yes, that's us. And it's live. And I'm playing. So I can't actually do what I'm doing real time. Interesting. So, no, that doesn't work. So I have to. Yes, that's us. And it's live. Not do that. And I'm playing. So I can't. Sorry, guys. I need to move it to there because oh yes, I can. If I know what to do. Turn the volume off here. Yes. Now I can see the live and I can see your comments. So please comment. I can see the live on the group, which is the first time I'm doing that. Hence the awkwardness to start off with. So this is all about welcome. This is the first time we're doing it in the morning. So welcome. The idea is to as of tomorrow, I will be doing actual activities, but today is an introduction for anybody that hasn't been before. It's all about finding the maths in games and finding the games in maths. So I'm going to change screen so I can see what I'm showing you. Monopoly Junior is a fantastic way of getting children under the 6 and under, or depends if they're on have special needs of any kind. You can go older. It's basically anyone that hasn't got their numbers solid to 20. those are the numbers that you work with, up to 20, and they all count in ones. The money is all in ones, and they're engaging characters, and they have to count along the board, careful counting along the board. That in itself can be quite challenging, and it's a family game. You can all play together, and it's a lovely way of solidifying those skills and having fun as a family all at the same time. So that's something I highly recommend. So thank you. Who's the manufacturer? Sure, it's some famous company brand. I don't know, it's just a Monopoly. Thank you. Hasbro, thank you. Hasbro for good old Monopoly. Of course, and as soon as they become good and familiar with those numbers, then take them up to the big Monopoly, the big boy Monopoly, my grandson calls it. You don't have to play, you don't have to play the full rules, and you can help with the bank. But what I do is I get my grandson to be the bank, or I get him to tell me how much change we need. And he likes to play the big boy Monopoly. Of course, he doesn't even understand what a 500 is yet. But slowly but surely, the more we play the game, the more he will grasp the meaning of 500 without me having to actually do a lesson. Say, this is what 500 means. He's not ready to get that information. But just like with language, the more that you play the games and use the language, the more they grasp the meaning of it. And with maths, it's not about a technique, it's about the meaning of maths, the understanding of maths, and the having number sense, having shape sense, understanding the properties. Now, talking about which, hi, my cousin's on. Lovely to see you. Hi, Chrissy. And hi, Steve. Thanks for joining. Now let's see if there's anybody very quickly on the other one. Not yet. It's delayed. There's a delay there, which is a bit frustrating. Okay, so back to this screen so that I can see what I'm showing you. Now, I've got a few things here. So it's going to be a little bit of ideas for parents and a little bit of just do it. So I've got balloons and now I've got to do the battle of the climbing over things. This is what you get when you're doing things in your front room. I left it over here. Have you ever seen a square bubble? Well, right now here's a cube. Well, it's not actually a cube. We're going to be finicky here. It is the skeleton of a cube. It's just the edges of a cube. And we can, depending how old they are, we can just check that we know how many faces it's got. The faces are these are the faces, and these are the edges, and these are the vertices. One vertex, many vertices. If you stick to that language, you will always know what you're referring to. If you call that a side, then that could be a side, and then the other things become a side. It can be quite confusing. Whereas if you stick to one nomenclature, edge, vertex, face, and a 2D shape has faces as well. So this 2D shape here, which is a rectangle or an oblong, has a face on this side and a face on this side. So top and bottom, both, it has two faces, one above, one below, one to the left and one to the right. Okay, right, having said that, I'm going to get my hands wet first. No, I'm not. I'm going to leave that to the last. This is going, if that's the last thing I'm going to do, I've just realized if I do that, then I won't be able to do the other things. So one of the many things we're going to do, we're going to do arts and crafts, and we're going to do, well, last night we did a live on symmetry. So symmetry can be a very dry conversation, or symmetry can be fold a piece of paper in half and then imagine, what do you want to create? Imagine the half of what you want to create. Well, so far I've created a doll, I've created a butterfly. What would I like to create today? Oh, I know, wait, half of it. I've got to do half of it. So it's got to have It's got to be symmetry. I've got to do half of it. I know, I'm going to do something super simple. Since I'm live and under pressure, I'm going to make a now, I'm not quite sure. I was going to make a pagoda. Is it going to turn out like a pagoda? This is it. You're visualizing. You're using those visualizing skills and you're creating something special. Is it going to turn out like a pagoda? Not bad. And as I was making it, I thought, that is, of course, is the line of symmetry here, or the axis of symmetry. It's mirror symmetry, it's reflection. This is the same on both sides. And I thought, as I was making it, I wasn't sure it was going to turn out to like a pagoda. Not bad, not bad. These skills of visualizing and then creating what you're visualizing and doing it again and again and again and again, iterations. Instead of calling them mistakes, call them iterations. If it comes out bad, it's not rubbish, it's an iteration. The next one will be better and better and better. And as you grow, you learn. And I thought, well, actually, while I was doing it, I thought, well, what if we made, let's see if it'll work. Let's see if it will work. Oops, sorry, you can't see what I'm doing. Sorry. Da -dee -da 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 -da. I wonder if you can guess what I'm making. You could play it like a game, like charades. Guess what you're making. Dee -dee -da 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 -da. Guess what I'm making. What do you think I'm making? Guess what I'm making. Oh, that one didn't come off, so that wouldn't be symmetrical. Get that one off. It's not quite right. It's not quite going the right way, but you know what? It's an iteration. It's my first of the iteration series, so it's going to be the worst. And then the next one will be better, and they'll keep learning from your mistakes, learning from your experience. And I did do it wrong. They're supposed to go downwards. If they went downwards, what would they be? So you can just have loads of fun with learning how making mistakes aren't mistakes at all. They're iterations. And yes, they can learn that word. If they can say Tyrannosaurus Rex, they can absolutely learn iterations. The older you are, the more important it is. It's absolutely critical. Anybody that enjoys maths enjoys the process of learning, the process of struggling. And then when you finally get it, the sense of achievement is absolutely extraordinary. So I've made, well, it's a wonky palm tree. What, or you can call it, oh, look, it could be an underwater creature. I can just see finding something like that under the sea. Oh yes, I don't know what it is, but I've just made something for my sea. Oh, so now I've got the idea of making a collage of shapes. Maybe we could make an undersea creature collage, so we can have a nice artwork created as well while we do our lovely maths and symmetries. And then you can add colours, and you can add mixing colours and how all that works. And yes, that is mathematics. And you ask any artist whether or not, well, they might not say they're doing mathematics, but if you look at something, especially the ones that have a lot of perspective, well, anything that has perspective, draw a face. So, oh my goodness, the art that's out there, the artist has to have a feel for perspective. So, right, something else. We're going to do that last. We're going to do this one next because it's something that's fun. And there's lots and lots. Well, one day, one of these sessions will be nothing but Mobius strips. It'll be all about Mobius strips. So this is an example. You just cut a strip of paper. The longer the better, really, but it needs to be a little bit wide. And you'll see why in a minute. And then what you do, well, let's start with just a loop. A loop. And if you hadn't thought about doing Mobius strips, of course you can always, we will have a lot on our own YouTube channel, but right now we don't have one on Mobius strips. So please do Google or YouTube making Mobius strips. And you're going to just start the cut and cut it in half. Well, actually, we might create a bit of symmetry here as well. We've got 2 loops. Of course we do. What else would we have? Well, let's cut another strip. As I say, one time when we do this, whoops, you can't see what I'm doing. one time when we do this, we will do nothing but Mobius strips. So for those that don't know what a Mobius strip is, have a look at this. You take one half and you twist it round. Now we're back to visualization, and this is a very important subject in mathematics called topology. Topology, and it's all about how many surfaces something has and whether or not, it's a whole subject in mathematics, is topology. And now, so I'm going to cut this one in half. So of course I'm going to cut it into two, right? What I did last time, so it must be. Let's see, cut it all the way down the middle, and two halves, right? Here we go. Oh, what? Wait, it's not two halves, it's one loop. And even better than that, if we get a marker, and purple in honor of my lovely Mark, my grandson's daddy. Here we go. Now, starting here, I'm going to make a cross so we know we're back. Whoops, that's starting there. Make there we go. Make a cross so we know where we started. I'm not. Whoops, I am going to raise it off the paper, but if you can do it without raising it off. There we go. Up here. That's where I need to be. Here we go. All the way around. Keep going. Always continue the line. Yep, continue the line. Whoops, over and under. Continue the line. Continue the line. Continue the line. Maybe if I do it further away. Continue the line. Continue the. Oh, crikey! I'm getting bored now. La 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 la. Wait, I found the cross. No. Whoa. Oh wait. No. Wait. What? I found the cross. But actually, there is something wrong here. Supposed to be one surface, the whole thing. I'm supposed to have gone all the way around. So, right. Well, anyway, investigate that one, and I'll do that properly another day. But you know what? That's okay. I make magnificent mistakes, and I learn from them. So I've got to go through that one more time, and also work out that I want to make that a bit shorter in length for this so that it doesn't take so long to do it. So I'll do that again. We'll have a whole session on Mobius strips. There are some amazing things you can do with Mobius strips. Right, and then we'll also do balloons. Let me see, what can I do with balloons? Okay, so a very, very simple thing. Now, this doesn't have to just be balloons. Whoops, maybe I'll choose a different color. I'm going to choose purple balloon. No, a white one maybe would give better contrast. Okay, so I'm doing this with balloons, but you can do it with any semi-rigid. So you can do it with pipe cleaners. You can do it with bits of cardboard even. You can do it, you just make long strips of cardboard just by taping stuff together. And what I'm going to do here is another important mathematical concept, which is called a continuous path. Now with 3D shapes as well, you can see what is the minimum amount of sticks or lengths that you can make a shape with. So there are clues, and there's something that we, over the course of the years as we're doing this, Bubbly Math has always been face to face, and now we're opening it up online. That gives me the opportunity and the team the opportunity to create loads of wonderful resources of all the things I've always wanted to share and haven't had an opportunity to do it. So here we go. Continuous path, in this case with a balloon. So when we go live, we usually do work with balloons, especially on stage with balloons and soap bubbles. So let's see, 1, 2, 3. Now you don't have to do it with balloons, but you can do it with balloons. 4, get some modeling balloons and have a challenge. So what am I making? What do you think I'm making? What do you think I'm making? Well, what have I made now? 1, 2, 3, 4 sides. So yes, it's a square. Another 2. What do you think I'm making? What do you think I'm making? You can talk about what you've made. Does it have any symmetry? Does it have rotational symmetry? That's what it looks like there. And then you turn it there. So that's a rotational symmetry of 1 over 1. The same there again, that's 2. And the final one, which we didn't count, is 3. This has a rotational order of 3, along the vertical axis? Well, that's just one little conversation you can have. Right, now, I wonder what I'm making. I wonder what I'm making. Note this is with one long balloon or long stick or long thread. If you've got a piece of wire, it's wonderful, perfect with a piece of wire. And I wonder what I'm making. 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 Another bubble. Put it on there. Ooh. It's harder to through. Another bubble. Let me just see if there's any comments or anything. Well, no, don't see any there, but then, and oh, hi Joanna. Hi Pindy. Hi Steve. Hi Terry. Oh my goodness, Terry. Hi. Hi Reese. Hi. Oh, it's Miss McGough, my English teacher. Hi Aileen. Hi Barbara. Hi Jan. Hi Steve. Oh my goodness, lots of lovely people joining us. And this one is, this just doesn't refresh enough to make a difference. So go back to the screen so I can see what I'm doing. And let me see, what have we got here? We're going to do with the last one. We're going to put it there. In. And we have a lollipop. We have a shaped lollipop. I'm just going to get rid of the bottom of it. Whoops. You could also make it, I do make these into flowers, by the way. This is the top of the flower, and I make geometric shapes for the petals or the sepals, depending which way you're looking at it. And hats as well. You can make a little hat like this and attach it to your hair with a little rubber band or a bit of balloon. So what have we got? We've got this shape. It's all made up of triangles. It's got one, let's go that way. 1, 2, 3, 4 triangles. And now it's got lots of symmetries. Turn it round. It's got another 1, 2, 3, 4 triangles. And that's all it's got. It's got the 4 underneath, the 4 on top, which makes a total of 8. And whilst at a very, very simple level, it's all you have to do is count the faces. Just notice its properties. Count the faces. And the one thing we don't want to call it, now, Miss McGough is the English expert. She's on here. She'll tell you in English, diamond is an excellent word. We love the word diamond. It evokes such amazing images. You can use it in your writing, in your prose, and your descriptions. In the language of mathematics, diamond is not a word. It's not used, because you say the word diamond to a mathematician without describing the shape, and they'll go, what are you talking about? And one of the huge problems with the word diamond is that especially young children of lots of ages, that's a square, more or less, and they'll call that a diamond. And that's not a diamond, that's a square, rotated by 45 degrees from that position. But that's perfectly valid to start at any position. I do encourage you to actually, whenever you draw 2D shapes, to not draw them flat on their base. Draw them any way around, any which way around you want. And triangles are the same. Let's make a nice right angle triangle here. It doesn't have to sit like that or like that. Draw it like that or like that or like that or like, anyway, it's still the same triangle. That's a really important little feature to be aware of and to use. And right, so now, what is this? It's got 8 faces. So it's got 8 faces, 8 triangles. Each face is a triangle. It's got 12 edges. You can look at that if you create it. How many edges has it got? How many vertices has it got? All of that, the properties of your shapes, and this is that. It does have a name, and it's not a diamond because a diamond is ambiguous. So many things can be called a diamond. It's got 8 faces. What creature lives at the bottom of the ocean and has 8 legs? Well, it's got its head inside its legs, so it looks like this. Or its beak, anyway. Octopus. Octa means 8. So it's an octa something. Now, this is a word that I don't think I'd ever heard when I started actually learning how to facilitate maths. And it's the other word is, the other part of the word is hedron. the official word for this is 8 faces, but it's in ancient Greek. So it means 8 faces, but it is in ancient Greek. So it's octahedron. Hedron meaning faces or face. Octahedron. 8. It must be faces. Hello, because it's there are many faces. So octahedron. Many 8 faces. Right, that's that one. That's another thing for today. And the last thing we're going to do today, we're going to do this every day at this time. So please do join us. Please do invite others to the group. That's the Making Maths Fun group. There will be links below. And this will also go up on YouTube. So there'll be links below for places you can go to do activities. And we'll be doing this every day with different things happening every day. Please do put in requests if you're having any problems with maths at home. I know in a lot of parts of the world right now it's Easter, so we're just making this fun. Well, it's fun anyway, but we're not expecting parents to be in learning, teaching mode. So don't worry about that. But please do at any time. This is going to this is going to be here ad infinitum as long as YouTube lasts. So please do send us a message, comment with any questions, any difficulties you've got, and we'll do our best to help you out. So here we go. Remember that, let's hold on, let's not spoil the surprise. Remember the cube, and some of you might not have seen the cube before. This is just a skeleton of a cube. It's not a cube, it's a cube, it's a solid. And if it was a cube, it would actually have 6 solid faces. Imagine it was filled with chocolate. Then it would be a cube. Oh, cubic Easter egg. Oh, okay, right. Now I'm going to fill it with bubbles. I love bubbles. You see that bubble in the middle there? Now bubbles make minimal surfaces. And look what happens if I break the center bubble. Wow. That is the minimal surface, the shape that you'd need to make a material if you wanted to join all of those 12 edges together around the edge and not through the center, so you could have a tunnel in the middle, so you could join, be a good shape to join the space station to the space shuttle if the frame were this shape. Now, a bubble is a sphere, right? Who wants to see a bubble? A nice sphere? Oh, that's not spherical. That's not a sphere. That has 6 faces. But you know what? It also demonstrates beautifully something that helps you understand the properties of something or the meaning of something is to see something when it's not that. So in this case, on the red one, every face is a square. It's got 4, it's a closed shape made up of straight edges. And in the case of a square, every angle is 90 degrees. Whereas with bubbles, never have 90-degree angles. That's why they show us the minimal surfaces. So none of those angles are 90 degrees. None of the edges are straight edges. They're all actually an arc of a circle, a small part of an arc of a circle. And the faces, if you can see that, they're all curvy. They're a part of a dome of a sphere. They're a part of a sphere. It's called a dome of a sphere. So if you merge 6 spheres together and join them in the center, that is the shape that you would get if you could converge them in the center like that. Now let's see if we can make a sphere. See if we can do it. See if we can make a sphere. Here we go. It's going to come down any second now. Ah! There you go. I love bubbles. Oh, and the rays of sunshine are shining in. So thank you for joining us. Same time tomorrow, 9 o'clock. I'm Caroline from Bubbly Maths. And then we've got the YouTube channels. We've got the Bubbly Maths YouTube channel. We've got Maths Toys YouTube channel. They're all being developed and populated as we speak. And then we link to Aiming High, which is an organization in Africa that provides professional development to teachers in Africa that work in disadvantaged and rural communities. And they've created some amazing resources, which we are very privileged to have access to. And by doing that, we can help them promote what they're doing and help promulgate their works. So I think I just used that word, just came out. I don't I'm going to have to look it up now to see what promulgate means. I hope I used it correctly. Thank you, everybody. See you tomorrow, same time, 9 o'clock in the morning, London time, and 8 o'clock in the evening, London time. Bye-bye. Oh, how do I? This is, I'm just, yeah, being my own technician. Stop live stream. Bye.